Hi everyone. So let's start our analysis. Now we are going to do few more questions analysis, right? So Deepak has solved some questions, but now we are going to see some more questions. Let me know if my audio and video everything is fine. So before I go further, let me quickly introduce that I'm Sachin and I have finished my masters from IISc. I have achieved GATE All India Rank 33. Okay, so let's start with the very first question, which is this one, which is directly taken from Galvin. So if you see this question, this question has been directly taken from Galvin. This question is asking that which of the following algorithm can result into starvation. This question is from Galvin. You can go to the chapter number 5 and in this chapter you can find this question. So options were also same. They have asked first come first serve, or maybe I think the option was first in first out, which is same, right? First in first out. First out. This was the option there. So which is same as this. Now they have asked that which of the following can result into starvation. See, it is very clear that the shortest job first can definitely result into starvation. Why? Because the shorter job will keep on coming and you will never get a chance to the jobs which are having the longer burst time. So basically, this will definitely lead to the starvation. Similarly, the priority scheduling will definitely lead to the starvation. Why? Because the higher priority jobs will keep on coming, right? Higher priority jobs. Now, there is very interesting point is that will first come first serve or first in first out will result into starvation or not. That's very interesting. So let's just see the answer that is directly from Berkeley University. If you see, I have taken this PDF from the Berkeley University and they have clearly said that yes, if the task never yields, which means that even first come first serve can go to the starvation if you are having the infinite loop, which means let's suppose, okay, suppose there are a couple of jobs and the first job which is coming is just like this, while one. Suppose the first job is having this while loop and it is basically never going to halt. Let's suppose this is saying that printf hello, something like this, right? Let's suppose this is your first job. Doesn't matter what is your second job, doesn't matter, right? Doesn't matter what is your second job. If you are having this as your first job, then definitely if this job is going to submit to the CPU, then what will happen? Tell me, will this job ever going to halt? Let me know. Will this job ever going to halt? No, right? This job will never halt. So that is why, since this job will never halt, that is why you can say that this job will result to the starvation to the other jobs. So because like this job is saying that while one, see here while one, that's what the Berkeley University also says. See the Berkeley University PDF, it is clearly written, if a task never yields, that means that it doesn't produce any output, and it never yields means yield means output. It doesn't produce any output, it goes to the infinite loop. If it is going to the infinite loop, then why not? They have clearly said that. See, this is not a Honolulu University, this is Berkeley University. So Berkeley University is clearly saying that if the job is the infinite loop, then why not? So that is why even this first come first serve can go to the starvation. This question is directly from Galvin. If you go to the chapter number 5, chapter 5 Galvin, then you will find this question. Even in the Berkeley University assignment, okay, even in the Berkeley University assignment, there was one assignment. Okay, this is some assignment, some midterm solution, midterm 1 of fall 07, which means 2007 fall midterm 1 solution. In that solution also, they have said that FCFS will result into starvation only if the threads runs forever. So even FCFS can go to the starvation. See this clearly. That is given in the Berkeley University, which is known to be the top-notch university in this world. So they have clearly said that you can go to the, like, I mean, the first come first serve algorithm can even suffer from the starvation. Even like not just first come first serve. What they have said, that this is the problem with all the non-preemptive schedulers. This is the problem not just with the FCFS or maybe any particular non-preemptive. It is a problem of the non-preemptive schedulers. Now I know what is your question. Now you will say that what if you have the higher higher time quantum for round robin, and why not round robin for the starvation? Can anyone tell me why not round robin? If FCFS can go to the starvation, then why not round robin? Can anyone tell me quickly? Because the reason being is that this round robin scheduler will be having the finite quanta, whatever it is, right? It will be having the finite quantum. Now you will be saying that this finite quantum, let's suppose you will be saying that this finite quantum is too big. Let's suppose you say that this is 1 year. I mean, you will be going to run one job for 1 year. That's fine as long as it is finite. Okay, as long as this number is finite, however large it is, I don't care. However large it is, I don't care. Okay, as long as it is finite, I will say that okay, there is some finite amount of time that this job one will run, and after this finite amount of time, which means this finite quanta is over. Okay, whatever it is, it may be very large, I don't care about it, it may be very large, but whenever your quanta is getting expired, then the next job will get scheduled, right? The job 2 will get scheduled. So that's why this round robin will not go to the starvation, but FCFS can go. This is where most of the students, I think almost all of the students has went wrong. And to be honest, like I was thinking to put this question in weekly quiz, but then I thought that okay, let's not put this question. I don't know why I haven't put this question, but I actually copied this question, and I have almost put this question in our Go classes weekly quizzes. But anyway, I have not put it ultimately. That was just a bad luck for me, I mean for us. But I hope now you understood that why FCFS, even the FCFS can go to the starvation, right? Let me know if there is any doubt here. Let me know why FCFS can go to the starvation. Let me know if there is any doubt. I hope you understood. Okay, so okay, now this question, for this question, FCFS is the answer, that it can go to the starvation. Shortest job first can go to the starvation, and priority scheduling can go to the starvation. So if these are the options, I mean the order of the option is, if this is same, then I will say A, B, D, and A, B, and D are answer. C can never be the answer, because however bigger quanta you have, round robin will never go to the starvation, because after some finite amount of time, you will say that okay, you are going to schedule your job, right? After some finite amount of time. Okay. Let's move to the next question. See, even the Berkeley University assignment has the same question, and I was thinking to put that question in the weekly quiz, but anyway, let's not worry about it. So let's move to the next question, which is also very interesting one. So do you remember this question? This question is from computer networks, right? Computer networks question. They have asked that okay, 9 in non-persistent and with the five parallel connection or not, right? So they've asked this question. In the examination. I hope the options are correct. Let me know if the options are correct or there is some confusion with the options. I think the options are correct, right? So let me tell you, for this question also, we have put the similar question. In our one of the CN test, and the question is this. So we have put that similar question. In that question, we have put something like this. So we were saying that we have put there were two questions in this university from where I have copied this question. I have put there are two parts, 7 and 8. I have put the part 7. Okay, I have put the part 7, but I have not put the part 8. But yeah, that's okay, because both are the similar questions. So see, in this particular question also, they have the same thing. They are saying the 5 parallel connections. If you remember that this was the option even in the GATE, right? The 5 parallel connections. In our Go classes test series, Go classes computer networks CN4 test, we put the part 7. So here we had the two questions, 7 and 8. From that I have put the 7, and this is the question number 8 they have asked. I mean both are the same, and which is basically they have taken from one of the university. I can even tell you the university name. Okay, let me just check the university name. So this is the URL of the university. Let me just put the URL. So this is the URL of the university, and from that URL they have taken this question. Maybe they have taken from somewhere else, I don't know, but what I'm saying, that one of the part we have put in our Go classes test series. Okay, so let's just continue with this question, that what they are saying. Okay, so Gamer is saying that Sundrit is there. There is some user who is saying, thank you sir, I did FCFS, priority scheduling and SGF, but everyone is saying that FCFS cannot start. So he's saying that everyone is saying that FCFS cannot starve. But yeah, I mean, mostly, most of the people will be saying that FCFS cannot starve. But see, the standard universities are saying that FCFS can starve. So FCFS, even the FCFS can starve. So just see the Berkeley University, which is known to be the, I think, I do not know the ranking, but I'm sure that Berkeley is under top 20, or I won't be surprised it is in top 10. Okay, Berkeley is one of the top university that even for machine learning assignment we used to refer at the Berkeley University in IISc. Okay, so let's just continue. Actually, there is one professor, and I forgot his name, Sri Hari. Some professor is there at Berkeley University. He used to teach machine. He used to teach machine learning at Berkeley University, and he is from IISc actually. So he used to deliver the guest lecture at IISc. So from there, I got to know this Berkeley University, and then I got to know, okay, this is one of the top notch university in this world. Yeah, this was very nice question. I think they have said, like, if you are doing thread context switch, see, many times, I mean, many times in our Go classes course we have dealt with these kind of things, right? If you are doing thread context switch, if you are doing thread context switch, then I think they have asked that what do you need to save? See, thread locally do something, right? They do some computation, so they have their own registers, right? They have their own registers, so maybe you need to save registers. I mean, can you tell me what was the options? Registers, stack pointer, I think, page table base register, and do you remember what was the other options? There was one more option that was okay. I think. Can anyone quickly tell me what was the other option? I think stack pointer, registers. So anyway, okay. Can anyone tell me? Page table based register, stack pointer. Yeah, that's so general purpose register. Program counter. Yeah, program counter. Program counter was the option. Okay, okay. So what do you think? What should be the answer? Let's suppose this is A, B, C, D. What do you think? Page table based register is definitely not the answer. Why? Because this is the same process, right? This is the same process. Same process. And apart from the page table based register, program counter should be the answer, because everyone is executing some different code, right? So program counter should be the answer. Everyone is having their own computation. They are saving some different values. So general purpose register should be the answer. Everyone is having their own stack, so that's why they need to save the stack pointer. See, whatever they are owning, I mean, whatever is not shared, they have to save it. So that's why A, B, and D is the answer, right? A, B, and D is the answer. Yeah, right. So A, B, and D is the answer. I hope you understood. And why that is the case? Because general purpose register means मतलब वो locally कुछ पका रहे हैं ना. Let's suppose you are a cook, you go to a kitchen, right? You go to a kitchen, you do some computation. तो locally आपने जो किया है वो आप अपने आप को सेव करोगे, मतलब अपना ingredients हर चीज आप अपना लेके चलोगे, right? And similarly for the stack pointer, similarly for the program counter. But this is the same process. That's why the page table based register is not they do not need to save for the thread context switching. That's the thing that we have. I mean, multiple time we have discussed in our Go classes courses. Okay, there was one very nice BFS question. What was the question? Let me just recall it. I think question was saying that there are two sets A and B that are the subsets of power set of two of u, right? Power set of u, which means, and u is given to be 1 2 3, and then they said like A is not equal to B and A is a proper subset of B. I think they have said like it is a proper subset, which means A cannot be equal to B, and or maybe B is a proper subset of A. If that is the case, then you are having an edge between A to B, right? And then they are asking that like, I mean, they have defined some function b of phi. They have asked that okay, b, they have defined that this is the number of BFS ordering possible, right? So they have said like, let's suppose b of any set A. Okay, this is number of BFS ordering possible. So that's what they said. Now then they have asked B of phi. So what is B of phi? So this was a nice question. Let me quickly tell you that what is B of phi. What answer did you get? Let me just know. What answer did you get for this B of phi? Okay, see, yeah, 7 factorial. Why? Because 5 is a proper subset of anything, right? Of anything. So how many total number of elements in power set, in power set including 5, it will be 2 power 3, because u was given to be 1 2 3. So including 5, it is basically 8, right? It is 8 including 5. Now if 5 is there, then 5 will be connected to everyone, because that's what they have given. Like, a set is connected to another set only when it is not a it is basically a subset, and not equal to another set. So basically there is no self loop, right? I mean, a not equal to b means there is no self loop, and this is connected to everyone. This is connected to everyone because 5 is a subset of everyone. So this is connected to everyone. Let's suppose these are the remaining seven sets. So if you're doing BFS, then you can either start with this, or maybe with this, maybe with this. So basically there are 7 factorial combinations. There are 7 factorial combinations where you can do your DFS, right? BFS, sorry. Let me know if that is okay to everyone. So that was a nice question, and yeah, so that's how you can do this question. Okay. So then they have asked that what is the maximum heap, and maximum heap extract max. Extract means they want to delete it also. They want to delete it also, and insert time complexity. Both are log n, right? It was an easy question, order of log n. Why? Because in max heap, if you want to extract the maximum, then what you will do, you will be basically swapping it with the leaf node, and then you will be doing the heapify here. So you can take the log n time here. Similarly, if you want to insert something, then this insert can propagate up to the root, and then in worst case it can take again log n time. So that's why both are order of log n only, right? Yeah, log n for both. Yeah, that is right. That is nice. Okay, great. So let's just continue. Yeah, BFS ordering, this question we have done. Yeah, so this was one easy C programming question. What they have said, they are asking that what should be the value that is getting printed. I do not remember the answer, and I'm not sure if that is the same question that they had, or maybe some different question. I think that's the same question. So if that's the same question, then you will be getting XH2, and then you will be calling it again. So here it is 2 plus and I mean it will be 2 plus plus, which will be 3. So you will be writing 3 here, and I think, okay, this is x or y, should be x, right? So and then plus 2. So basically x will be 2, y will be 5, and then finally x plus y should be 7. So 7 was the answer, right? Okay, if this code is correct, then 7 is the answer. If this code is not correct, then there will be something else. See, don't get confused with this x. That I'm sure that I mean this x was different. So these two x are different. Don't get confused with this x and this x. This x is local x. This x is also local x. So don't get confused between these two x. These two x are not related to each other. So whenever you are having this x, this is just local x. These both are local x basically. Both x are local. It is just that it is static. Okay, it is just that it is static. It won't change anything. Let me know if you have understood this correctly. Okay, so Kami-san is asking, sir, do you think GATE 2024 will be the most trickiest one, because it will be conducted with ISC? See, we cannot say anything. I mean, honestly, like if that happens, then it is good. To me, it is actually good. I mean, I actually want paper to be little conceptual. I mean, not very straightforward, because it is not fair to every student. So if that happens, then I'm happy if that happens. But nobody knows. Like, I mean, these kind of predictions cannot be made. So nobody knows actually. Okay, nobody, absolutely nobody knows. Absolutely nobody knows. Okay, okay. So here, yeah, it is plus x, right? Cool. Yeah, so this was one question, which was activation record. They were asking that activation record tree. I think the question answer, I mean, if that's the question, I think that was the easy question only. They were calling some, I mean, main was calling F1. So main is calling F1, and then after some time it will call F2. Then after some time it will call F3. F1 will return, but F2 is a little tricky. F2 is calling F3, and then it is like then I think F3 just return, right? F3 just return. So then it is calling, if n is 1, then it is calling F1, but initially n is 2, so it is calling F2, and then F2 again. I think okay, I think something is there. I do not exactly remember. I mean, what was the question? But I think something like this, right? Something like this. So if the question is like this, then this is the diagram. Okay, or maybe there is some manipulation in the question. I do not exactly know. Maybe okay. You can just do this question based on the actual question that is given there. Cool. So let me know if there is any doubt. We will be taking more questions, but for now, let me know. So Deepak has already taken some questions that was from OS, and I'm not going to solve those questions again. I mean those questions that were related to semaphore. There was one question that was related to semaphore. There was one question that was related to LRU. These questions has already been taken. You can just watch the part 1. Okay, Deepak has solved nicely. So these were just easy questions, and we have already done it in the part 1. The semaphore and LRU, both of these questions are very standard questions, and we also have these almost same questions, even more trickier questions. Okay, almost same in Go Classes test series. We have in Go Classes tests. We have almost same question in Go Classes test. Let me know if anyone has solved these questions. Okay, this is n minus 1. Yeah, F2 of n minus 1. Yeah, right. So then it will be calling with 1. So then I think this F2 will be calling F1. Something like this, right? Cool. You can do this question later. Okay. Yeah, there was one algorithm question which is very nice question. Let's just solve this question. Let's just see what this question was saying. See, in this question, mostly people get confused that answer should be n log n. I mean, here it was basically getting compared with I equal to 1 to 100 into n with this for loop, right? So now here mostly people said that answer is n log n, but no, why answer is no n log n? I mean, answer should be n only. Let's just see this question very quickly. So see here, first time loop will run n time, and then they are saying n equal to n by 2. Now the loop will run n by 2 time, then n by 2 power 2 time, then n by 2 power 4 time, and then similarly n by 2 power k, which is finally 1, right? Which is 1 time. So it will basically run like this. Since it is decreasing GP, as I told many times, if it is decreasing GP, if you want to find the order, you just take the first term. If it is increasing GP, you take the last term. But if it is decreasing GP, you can just use a shortcut, which is take the first term, which means it is just order of n. If you want, you can even solve this, right? I mean, you can just solve this, and you can take common 1 plus 1 by 2 plus 1 by 2 square till 1 by 2 power k, right? And here I know that n upon 2 power k, basically, I mean, it is basically something like this, and n upon 2 power k is finally 1. So I mean, I'm stopping at n upon 2 power k, which means n upon 2 power k is finally 1. So this thing is finally 1, right? That's what I already know. Okay, so I know that n upon 2 power k is 1, which means 2 power k is n. Okay, 2 power k is n. Anyway, let's not worry about it. Let's just solve it. So like here you can use the formula, which is a into 1 minus r power n upon 1 minus r. So what is a? What is your first term? First term is your 1 minus 1 minus r is your 1 by 2. N means number of terms. I think number of terms are here k plus 1. So you can do k plus 1 upon 1 plus 1 minus r. 1 minus r means 1 minus 1 by 2. So into n. Whole thing into n, right? So that's how you can solve this. So let me quickly solve this, and let's just see what is the final answer we are getting. So it is n into, now you just see here, it is 1 minus 1 upon 2 power k plus 1, right, upon 1 by 2. So that's what we are saying. Now let's just solve this, and let's see what is the answer that we should be getting. See here, now this thing is 1 by 2 into 1 by 2 power k, and 1 by 2 power k is known to be 1 upon n, because 2 power k is actually n. 2 power k is n, so it is 1 upon 2n. So 1 minus 1 upon 2n upon 1 by 2 into n, right? So it is 2n, it is basically 2n. You can just do 2n minus, you multiply 2n minus this, it will be 1. So finally it is 2n minus 1, right? 2n minus 1 will be the answer if you find the exact summation. But anyway, it will be just order of n. As I told multiple times, that if it is decreasing GP, you can just take the first term. If it is increasing GP, you just take the last term. Okay. So yeah. So that is the answer. Yeah, while n is greater than 1, yeah, okay, doesn't matter. Maybe you can write, yeah, I mean, it is better you write n is greater than 1, right? Okay. So So this is order of n, this is order of n, this loop is order of n, this loop is also order of n. Since both loops are order of n, that's why you can say, I mean, this is running n time, this is running n time, or maybe exact 2n minus 1 time, and this is running 100 n times. So one function is 2n minus 1, another function is 100n. They just ask you to compare these two functions. They are just asking you to compare these two functions. Tell me what should be the answer. So what do you think? What should be the answer? Both functions are actually equal. So that's why you can have theta, you can have big O also, or you can have big omega also. But I think big omega was not in the option. So that's why theta and big O is answer. Small omega or small o. Okay, this O is small o. Small o. These are not the answer because both functions are actually same asymptotically. Okay, let me know if you have understood this. Yeah, theta. Okay, Mohanis is saying that unable to find OS discussion. It is there in the part 1. Okay, it is there in the part 1. You can just check it out. Yeah, now let's just do this probability question. I think it was just easy question. They are saying A is an event that had on the both flips. B is in the event which is saying head on first flip. C is an event which is saying head on second flip. Now they are saying that whether A is independent of B or not. So tell me, will this be correct? Let's just check it. This is saying A intersection B upon probability of B, right? So if this is actually coming out to be, if finally let's suppose this come out to be probability of A, then I can say A and B are independent. But let's just check whether it is coming out to be like this or not. So what does this mean? That it is saying that both are coming to be head and first is coming to be head. So basically B is just a redundant thing. So you can just say probability of A upon probability of B, which is actually not equal to probability of A, right? Which is not equal to probability of A. Since it is not equal to probability of A, that's why you can say that this A and B are not independent. Similarly, A and C are also not independent, right? So you can say A and B are dependent because they are not independent. Similarly, A and C are dependent. Now, what about B and C? B and C are independent. Why? Because you can quickly check it out like this also, maybe using the formula. Okay, it should be equal to probability of B. How? Let's just check it out. It is probability of B intersection C upon probability of C, where it is saying head on the first and head on the second. Since by construction means the way we are designing the problem, these two are independent, right? I mean this B and C are basically probability of B into probability of C, right? Because head on the first and head on the second, it is just the probability of A. I mean it is just A. So basically you divide by probability of C, you get it cancel out, and then finally you get probability of B. So which means this is same as probability of B. So that's why these two are same, right? Okay. Yeah, now let's see this question. Singly linked list was given, doubly linked list was given, and then they are saying that if you want to delete where the head pointer is given, head pointer is given, and one thing is the node to the pointer is also given, node to the pointer, right? In both the cases. So if it is singly linked list, then it will take order of n, because if the head is given and this node to the pointer is given, if you want to delete this, then you have to first traverse this till this point. Why? Because you want to make this 2 point here, right? This 2 point here. So to access this pointer, you have to traverse till this point. So that is why here it will take order of n. But in case of doubly linked list, if you want to go here, see, in case of doubly linked list, if you want to go here, then you can just go in order of 1. That's why in case of doubly linked list, it will be taking order of 1. Okay, let me know if you have understood. So yeah, these are the questions that I currently have. Now let's just do one thing. Let's just compile. Okay, let's just compile all questions. So what you need to do, you just put a comment in this video, and just put a comment in this video with the question. Okay, whatever you remember, with the question, whatever you remember, we will be just conducting one more session to compile. After compiling all the questions, just put all the put a comment and then let us know what is the question, and then we will be solving it. It doesn't matter. See, for the Go classes, we don't care whether it is a tough question or easy question. I mean, unlike other coachings, we don't care whether it is a tough or easy question. For us, every question matter, and we will be solving every question. So don't worry, we will be solving every question. What you just need to do, you just need to put a comment. Okay. Yeah, that question, Monis, is also discussed in the part 1. You can just see the part 1. So just put a comment with the question, and then we will be solving in the next session. Just let us know what was the question. Till then, take care. Bye bye. See you. I hope you liked all the discussion. So especially all the questions that we have taken here was the nice questions, and then we will be conducting one more session telling you that what are the answers for other questions.